Hi, everyone. In this video, we will focus on section 5.5, and we are going to take a look at graphs of sine and cosine functions. So let's take a look at the basic graph of the sine function, where y is equal to sine of x. We have taken a look at the unit circle. So how do we graph y equals sine of x onto the y-x plane? First, how we graph this is, before I show it to you on the graphing calculator, is we are going to have the y-x-axis. And what the y-axis, the x-axis is, it's like your, maybe I'll do it this way. X is kind of like your angle. So it's, let me just go ahead and label this theta. So it's your angle measure in radians. And the y for the y value is the y value for the coordinates. Okay, so think about the x-axis as your angle measure and your y value as the y coordinate of on the unit circle. So first, if we start on this point, if we graph that, and we said 0 radians, what is the y value of that coordinate? Well, it's 0. So at 0 radians, the y coordinate or sine of 0, actually, let's make a chart here. This is theta, this is the, this is sine of theta. When it's 0 radians, sine of 0 is equal to 0. So there's our first point, 0. The second point we're going to focus on is pi over 2. When your angle is pi over 2, sine of pi over 2 is 1 because the y value of that coordinate is 1. Let's get pi over 2 on there. So pi over 2 is 1. And then pi at sine of theta is 0. So sine of theta is equal to pi. And then we're going to go down here at 3 pi over 2. At 3 pi over 2, sine is -1. And then lastly, we're going to go back to, let me try squeeze 2 pi on this. 2 pi, it's 0. So at 3 pi over 2, it's -1. And back at 2 pi, we go to 0. So here is one period or one full, I guess because we went one rotation, we call this one period of the sine graph. We could continue this on and on. If I were to continue this on forever, this would keep going. Okay, what the amplitude refers to is from the midline, how high up and how low does it go? Well, the amplitude is 1. And period, because this is the basic graph of the sine function, is 2 pi. And I'm going to show you how to do it on the graphing calculator. So first, make sure that you're in radian mode. And then go to y equals, and we're going to type in sine of the x. Before you hit graph, you want to make sure that your tick marks or your window matches what we have on this page. So go to window, and for x minimum, I'm just going to go to, I'll start at 0. Let's just do that. Let's start at 0. Your maximum will end at 2 pi. And your x scale, it's how, instead of going up by ones, we're going to go up by pi over 2, right? Because we're going up by pi over 2 units each time. So pi over 2, my y min is going to be -1 because -1 is the lowest we'll go on the y value. Our y max, not 7, it's 1. Right, then we hit graph, and there it is. It's this portion of the graph. And your tick marks, right? We made the tick marks in such a way so that, right, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi, and it's going up from 1 to -1. Okay, so this is one full rotation. Of course, if I had made this bigger, like if I had made this like say -4 pi all the way to 4 pi, just to get a bigger view or a bigger domain. Oops, let me go back. I messed up. So -4 pi to 4 pi, and then x scale is pi over 2. You can see the sign, it's, it keeps going and going and going if I made my domain a wider value. So there's the basic graph of the sine function. Let's take a look at number 2. What if we had sine of 4x? And so the basic function is sine of x. Oh, let's take a look at the basic graphs of y equals a sine of bx. And you could have parentheses. Sometimes we put parentheses around the bx. So amplitude, it's whatever the positive or absolute value of a is. So whatever is this value, take the absolute value of that. The period is whatever 2 pi over b. So the value in front of x, this b, depending on what that is, to get the period, you take 2 pi and divide b by it. Okay, so let's take a look at the next example. So number 2, sine of 4x, the amplitude is, right, the number here. Well, in this case, it's 1. I don't see any number, so we assume the amplitude is 1. The period is 2 pi divided by b. B in this case is 4. So we're going to take 2 pi over 4. 2 over 4 is 1/2, or pi over 2. Okay, so I know one full period before on the original graph, right? One full period used to be 2 pi, but now it's much shorter. It's pi over 2. So how we graph this is we have to locate 5 points. And how we locate those 5 points is we start at 0. So let me make a table. Where x is your radians. So at 0 radians, if we do sine of 0, that's going to give us all the y values. But to get to the next value, we're going to say pi. Let me go backwards, actually. I forgot a step here. Okay, so what we need to do is find the x values. We're going to take the whole period and divide it into 5 parts. And by that, what that means is I know that we want to start at 0, right, on the graph. And I know the full period is going to be pi over 2. but I want to split this up into 1, 2, 3, so 5 parts. But I don't know what these values are. Like, what are these values, these tick marks? If I know that the whole period is pi over 2, and I need to get what these tick marks are. So what you do is you take pi over 2 and you divide into let me just go back, and actually we want four tick marks. I think I got one too many. So I'm dividing this into 4 equal parts, and we want to find out what this value is, what this value is, and what that value is also as well. So to do that, we are going to take the whole period and divide by 4. And the way we divide by 4 is you take pi over 2 and you multiply by the reciprocal 1 over 4. We get pi over 8. So this first value is pi over 8. To get the second value, what we can do is take 1 over 8 and add another 1 over 8. And let's make it a fraction. That's 1 over 4, so it's going to be pi over 4. And then add another 1 over 8. Make it a fraction. So this becomes 3 pi over 8. And if we add another pi over 8, we end up with pi over 2. And I'll just show you that that is the case. And so half, it's 1/2, which is pi over 2. So there are our points. And that's how we're going to determine what these values are in between. You divide by 4 because we're dividing the whole period by 4 right here. You are always going to divide by 4. And this is the what the units are how long each little unit is. And now we can graph this using the graphing calculator here. So sine of 4x. And then we can go to window. My x minimum is going to be 0. Your x max, the biggest x maximum is pi over 2. And my y scale or x scale is pi over 8. It's the period divided by 4. And let me just write that down here. Your x scale is your period divided by 4. And where that 4 comes from is, if you think about the unit circle, it's divided into 4 quadrants. So we take the period and we divide into 4 parts. And this is your x scale right here for this problem. So for this, it's pi over 8. Our y min, we'll keep it the same. We hit graph and we can see this is 0. At 0, it's 0, 0. At pi over 8, it's 1. At pi over 4, it's -1. At 3 pi over 8, 0. Actually, I went down too much. At pi over 4, it's actually 0. At 3 pi over 8, it's -1, pi over 2. So there is 1 full period of sine of 4x. Okay, let's take a look at number 3, sine of 1/3 x. So the amplitude again is 1. The period is 2 pi over b. In this case, 2 pi over b is 2 pi over 1 over 3. So I'm going to change that to 2 pi times 1 over 3. The reciprocal is 3. So it's 6 pi. The x scale, it's the period, which is 6 pi divided by 4. Because again, there's 4 quadrants, and 6 pi over 4, excuse me, is 3 pi over 2. So this time I know that we kick the graph here. If we begin at 0 and my full period is 6 pi, and I know we're going to split this into 4 parts. So here we have 3 pi over 2, add another 3 pi over 2. You can do this on the calculator too. Will be 3 pi is halfway between 0 to 6 pi, 3 pi over 2, and then add another 3 pi over 2. So if you're not sure, you can always use the calculator, adding the next one, 3 plus 3 pi over 2. If you make it a fraction, oops, I did something you weren't supposed to do. You're not supposed to do the pi part. So 3 plus 3 over 2. And 4.5, change it to a fraction, you get 9 over 2. So this is 9 pi over 2. Okay, so let's take a look at this graph here. And you can see the 1/3 in front of the x makes the period much longer, 6 pi. So changing the window, we're starting at x min and x max at 6 pi, and x scale is 3 pi over 2, and our y min, y max is going to stay the same. I may have done the window wrong, so x pi is 6 x scale. I forgot that I did not change this right here. So sine of 1 over 3x. So there it is. So you should get an idea of what like all the sine functions look like, right? They all start at 0. You can see they all start at 0. And I mean, if the amplitude's 1, it isolates between 1 and -1. So it starts at 0. At the next tick mark goes up to 1. The next tick mark goes to 0 again. The next tick mark goes to -1, and back to 6 pi. So all sine functions have this shape where they all start at 0, right? And then it goes up and then back down and over again. Okay, let's take a look at number 4. Y equals -6 sine of 4/3 x. The amplitude, it's whatever the absolute value of A is. In this case, the absolute value of A is the absolute value of -6, which is 6. Period is 2 pi over B. And B in this case is 4 over 3. So take that and do 2 pi, I'll write it here. 2 pi times 3 over 4, make that a fraction. So this becomes 6 over 4, which is 3 pi over 2. So there's our period. The x scale is you take the period, which is 3 pi over 2, and you cut it up into 4 parts, 4 quadrants. And I'm just going to put that in the calculator. So do 3 over 2, divide by 4. And let's make that a fraction. We get 3 over 8, so that's your scale. Or 3 pi over 8, rather. And so we can put in the graph now. I'm going to graph it. This is 0, and I know that the last one full period is 3 pi over 2. And here's 3 pi over 8. We add another 3 pi over 8. We're going to get 6 pi over 8 or 3 pi over 4. Another 3 pi over 8. I'm going to do that here. So 3 over 4, add another x scale of 3 over 8. Get 9 over 8, or 9 pi over 8. And then if we add another 3 pi over 8, we end up with 3 pi over 2 again. All right, so graphing, we get -6 sine of 4 over 3x take graph. And I forgot to do one thing. Forgot to change the window. So for the window, we start at 0. X max ends at the period 3 pi over 2. Our x scale is 3 pi over 8. Our y min, so now this is different now. Instead of going back from -1 to 1, now it's going to go all the way to 6 and -6 because that's our amplitude. So amplitude is how high it's going to reach from your midline or from 0. So for y min, we have -6, and for y max, we have +6. So if we hit graph, notice how now in the other graphs, we had gone up and then down, but because of this -6, it reflects it downwards. It still starts at 0, but now this is way too far down. Now it's going to go down to -1 first. So here we have 3 pi over 8, 3 pi over 4, 9 pi over 8. Then back to 0. So here the sine curve is flipped over because of that negative value. Okay, so let's take a look at the next example. So here is a graph where before we just x, but what happens if we subtract or add a number to that? So graphs of y equals a sine of bx minus c, there is going to be a phase shift. And how we solve for the phase shift is, let me actually make some space. How we solve for the phase shift is that we take whatever's in the parentheses, so here the bx minus c, set it equal to 0, solve for x. And how we can do that is we add c to both sides. We get bx is equal to c. And so bx is equal to c means we can divide both sides by b. And x is equal to c over b. So that's going to be your phase shift. What that means is that's where your graph can start. That's your starting point. Or it shifts it to that point from 0. So it shifts left if your phase shift is, if it's positive, if your C over B value is positive, it shifts right if your phase shift is negative. Okay, let's look at some examples. So here we have sine of x minus 3 pi over 2. So our amplitude is 1 because that's our a value. There's an implied 1 there. Our period is 2 pi divided by b. B in this case is also 1. B is the number in front of your x. So 2 pi over 1, which is just 2 pi. Your phase shift is whatever you set the parentheses, inside parentheses, to 0. And then we solve for x by adding 3 pi over 2 to both sides. And we get x is equal to 3 pi over 2. So there's our phase shift. I forgot to do that here, but we should also do x scale, which is whatever your period is, and we divide by 4 because there's 4 quadrants. So 2 pi over 4 is pi over 2. Okay, now the graph. Okay, so this is going to change it a little bit because instead of starting at 0, 0, our new graph now starts at 3 pi over 2. It shifted the whole thing to 3 pi over 2. And so for this, and this example here, I'm going to start at 3 pi over 2 and add pi over 2 to each tick mark. So if we were to graph this and type this in as sine of x minus 3 pi over 2, and there's the parentheses, and then we want our window to be, so your x min, how I want you to put this in is your x min can be your phase shift. So your phase shift is your starting point. So that's going to be your minimum value. So here, this is 0. Instead of starting at 0, we're going to start at 3 pi over 2 instead. And your x max is going to be the phase shift, which is 3 pi over 2. And you're going to add the full period because that'll show you where it'll end. And your x scale is going to be pi over 2. And your y min, y max is -1 to 1. Okay, so you get a nice picture of a graph. So it still looks like a sine graph. If you want to just start and go at 0 again, we can do that and take a look at the full picture. So you can see that it goes up and down and then up and down. So then here, I won't put the graph here in because there's a graph right here. So you can see, depending on your period, your phase shift, your graph does tend to change here, like for this one. Okay, let's take a look at number 6. You have y equals 2 sine of 2x minus pi over 2. The amplitude is 2. Period is 2 pi over 2, or 2 pi over b. In this case, b is 2, and that becomes pi. Your phase shift is 2x minus pi over 2. We set whatever that is equal to 0 and solve for x. Let's add pi over 2 first. We get 2x is equal to pi over 2. To cancel 2, we can multiply both sides by 1/2. Is that what cancels this 2 out? And then we're left with x is equal to pi over 4. So that is our phase shift. Let's do x scale. X scale is your period, again, divided by 4. Your period is pi, which you're going to divide by 4. And that's it. Your x scale is pi over 4. So if we start with graphing, here's 0. Here's pi over 4. Because that's where we start. Here's our starting point, pi over 4, and we're going to add pi over 4 each time. So pi over 4 plus another pi over 4 is pi over 2, we add another pi over 4. That's going to be 3 pi over 4. Another at pi over 4. That's 4 pi over 4 or pi. We're going to do one more, add another pi over 4. We're going to end up with 5 pi over 4. Okay, so let's take a look at this graph. Y equals 2 sine of 2x minus pi over 2. And then go to our window. I'm going to change the x minimum. I'll make that 0 again. I'll make my x 5 pi over 4. X scale is pi over 4. My minimum is going to be -2. This is because my amplitude is 2. And we hit graph. And so it goes from 2 all the way down to -2. And I'm just going to erase all this down here. Okay, so it starts down here, pi over 4, goes to pi over 2, 3 pi over 4, back down to down, and then 5 pi over 4. You can also, if you're not sure, plug in values if you want to as well, directly into the function to get your output. Okay, we're going to take a look at number 7, 1/4 sine of x plus pi over 2. Here, the amplitude is 1 over 4. Period is 2 pi over b. B in this case is 1 because the number in front of x is 1. So it's just actually 2 pi over 1, which is 2 pi. Our phase shift is whatever is in the parentheses, and you're going to set it to 0. Subtract pi over 2 on both sides. So we get x is equal to negative pi over 2. Our x scale is our period, which is 2 pi divided by 4, which is 2 pi over 4 gives us pi over 2. So in this case, we are going to graph, or our phase shift is negative pi over 2. And we add another pi over 2. We end at 0. Add another pi over 2. We get pi over 2. Add another pi over 2 to get tick mark. We get pi. And then another one. Another add pi over 2, because that's our scale. What we're doing, we're adding our x scale each time. Here's pi, or a pi plus another pi over 2 gives us 3 pi over 2. And if you're not sure with fractions, you can work with your calculator, make your calculator do the work. So let's put this in 1 over 4 sine, parentheses, x plus pi over 2. Go to our window. I'm going to start at negative pi over 2 because that's our phase shift. I want to start at my phase shift. And our maximum is 3 pi over 2. Our x scale is pi over 2. Our y min, y max, I'm going to make that I'll stay at -1 and 1. So you can see it's lower because my amplitude is at 1/4. So the highest it can go is 1 over 4. So this is 1 and this is -1. The highest it can go is 1/4 and 1/4. And so it's going to start at negative pi over 2. Here, pi over 2 is going to be 0 again, then go down, then go back up. Okay, so there is that function right there. Let's take a look at 8. 8 says y equals sine of x minus 3. So amplitude is 1, period's 2 pi. Whenever you're subtracting or adding, it does a vertical shift. So here we're subtracting 3. That means it's a vertical shift shift downwards 3 units. And so let's compare it with the usual graph. Let's just make this -2 pi and make this 2 pi and make that pi over 2. I'm going to compare this. Here's the basic sine of x function. So if we were to graph it, that's what it looks like. Okay. Let's make the window, I'm going to make the window bigger and say, let's go from -5 to 5. Okay, so there's our basic sine function. If I put another one here, sine of x minus 3, you can see the new graph, right? The whole thing shifted down 3 units. Right, so this went down 3 units. And you can tell by looking at what we're subtracting or adding. So the graph, I won't draw it here because you have the graph. So it's that graph right there. It shifted the sine of x function downwards 3 units. Okay, let's take a look at cosine. The cosine graph is the amplitude, the basic one is the same. It's 1, period is 2 pi. And for the actual graph, what we're doing here for this is the x is your radians, your y, what your y or output is the x coordinate for the unit circle. It's really weird because you're asking like the y value is the x coordinate, but that's the output. So x here, if you're in 0 radians, the x value is 1. If we go to pi over 2, the x value is 0. If we go to pi, the x value is -1. And then at 3 pi over 2, it's 0 again. And last one at 2 pi, going back around the full circle, 2 pi at 0. It's 1 again. So using that, the cosine function, what it looks like is at 0 radians, it's at 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's 1 again. So here it is. It doesn't look like a wave yet, but this also continues. Like if we were to keep drawing this, we would keep going. But instead of the sine function, remember the sine function started at 0, 0. The cosine function starts at 1. At 0 radians, cosine is 1. So let's do some transformations of different versions of the cosine function. So graphs of y equals a of cosine of b of x, the amplitude is the same as the sine function. It's the absolute value of a. Period is 2 pi over b. That's also the same. And so in this case, example, the amplitude is 1 over 5. And period is 2 pi over b. And b in this case is this 5 here. So 2 pi over 5. Okay, let's graph some of these. Number 10, we have y equals 4 cosine of x. And so the amplitude is 4. And here the period would be 2 pi over b. Actually, for the cosines, I'm going to do some of the homework problems with you so that I can show you how to do this with the homework from my math lab. So let me hop on over to the homework. Okay, so here's a problem that was, let's look at this first. Okay, so to do the basic cosine function, we already said that at 0, it's going to begin at 1. So that's the correct one. For number here, you would have to compare it to the regular function. So to do that, I would suggest using the graphing calculator. So the graphing calculator, okay, so to graph this, what you would have to do is type in 3 cosine or cosine of x, because you're comparing cosine of x, and then 3 cosine of x, because you're comparing the two graphs here, and go to window and change the x minimum. Our x minimum is going to be 0 because here it wants you to draw or be in the system from x min, and there's your x max. And so for x min, you put in 0. X max is going to be 2 pi. Your x scale is going to be pi over 2. Your y minimum, let's be the same as graphs on the My Math Lab homework problem and go from -4 to y max as 5. So I set my window accordingly, a graph. And so there's our basic function. It starts at 1, goes down to -1, goes back up, and then it starts at y equals 3. So that's where it goes from 3, goes back down, and goes back up. So the one that looks like that is C. Okay, let's take a look at number 16. 16 says cosine of 6x. So these are similar, right, to the ones we did. So amplitude is A. So in this case, it's 1 because there's the number in front of cosine 6x is 1. Next one is going to be period. For period, what we do is take 2 pi, divide by b. B in this case is 6. So 2 pi over 6, which reduces to 1 pi over 3 or pi over 3. So let's put that in. Then it's going to ask you to graph. The graphing tool in my math lab makes it so easy that sometimes I wonder if it's a good thing. But here is how to do it. You're going to pick the cosine function. Now there's a difference between the cosine and the sine function. This is the cosine tool. This is the sine tool. All the others, that's just for the other ones. But because we're doing the cosine function, you're going to click on cosine, click anywhere on the graph. Put your amplitude in. For our amplitude is 1. Our period, I forgot what we have put for period. What did we put for period? We put 2 pi over 6, which was pi over 3. And so just clear this and start over. There is no vertical shift and there is no horizontal shift and there's no reflection. So then we just click done, save, check answer. And so kind of like is automatic. If you just put in your tool, if your period, all that stuff, it just does it for you really. Okay, so here again, the amplitude is A. In this case, it's 1. period is 2 pi over b. B in this case is 1 again because the number in front of x is 1, so it's just the same 2 pi. Period. And the phase shift is, remember the phase shift is you set what's inside the trying to get my writing tool. You set whatever's inside the parentheses and you set it equal to 0. And you solve for x. In this case, we would add 3 pi over 2 to both sides. And you would get x is equal to 3 pi over 2. Okay, now comes the graph part. So you have to remember the period, the phase shift. Period is 2 pi, phase shift is 2 pi over 2. So click on that. We're doing cosine again. So pick the cosine tool. Period was 2 pi. The amplitude was 1. Vertical shift is 0. Horizontal shift is your phase shift. So in this case, it's positive 3 pi over 2. There is no reflection. Save, check answer, and that's it. Maybe we'll just do another one. Okay, let's do this one. Amplitude is A, or the 1 over 4. The period is whatever 2 pi over b is. So in this case, 2 pi over b would be 2 pi over 3. Remember, b is the number in front of x. So that's our period. And our phase shift is, we set what's inside the parentheses equal to 0 and solve for x. So let's add 2 pi on both sides. And get 3x is equal to 2 pi. Divide both sides by 3, and we get x is equal to 2 pi over 3. Oh, so it's actually turned out to be the same thing. So our phase shift is 2 pi over 3 as well. Okay, time for the graph part, which is really the easiest part after you find all that stuff. So we pick the cosine tool. Our amplitude is 1 over 4. Our period is 2 pi over 3. Our phase shift or horizontal shift again is 2 pi over 3. And then we save and then check our answer. So we're done. So the graphing part is super simple. If we were to just use my math lab just makes it super easy to do. So you can just do it this way. Okay, so let me just go back to the homework. Actually, the slides. So if we were to continue with number 15. So number 15. Okay, here's number 15. So the rest I kind of skipped because they were just very similar, and it was just I did want to take some time to show you how to do it on the my math lab. So number 15, we take a look at. We're given the function instead, and we have to come up with the graph itself. So here we have the graph. And it's a graph, and I have to first determine whether it's a sine or cosine function. With the easiest way to tell whether it's something's a sine or a cosine function is if it starts at 0, like the center here, 0, 0, it's going to be a sine function. If it starts somewhere other than 0, it's going to be the cosine function. So I know this is going to be the cosine function. So let me pick that and say it's not sine because it doesn't start at 0, 0. The other thing we need to know is 2 pieces of information. It says we have to get A and we have to get B. Getting the amplitude is simple because we can see this is the midline. We see how far up it goes, and we can tell that it goes up to 3 and -3. So I know the amplitude can either be, it is 3, so now I have to determine whether it's 3 or positive or -3. To determine that, if A was positive, it would have started at 3, but now you can see it, since at 0 radians, it starts at -3. I know that A is going to be -3. So we have cosine. To find B, remember the period was equal to 2 pi over B. So if we know the period, we can solve for B. And to tell what the period is, I'm going to start here and see, okay, one full period would be going up and then coming back down. And so we can see here, one full period is from 0 to pi. So there's one full period. So if my period is pi, and I set it up to 2 pi over B. To solve for B, I'm just going to make that a 1. And we can multiply both sides by B to cancel B out. And that will give us B pi is equal to 2 pi. And divide both sides by pi. And that gives us B is equal to 2. So here, I'm going to write -3 cosine of 2x. If you're not sure, right, it's a good idea to graph it. So I'm going to go ahead and graph it to see if that's what I get. So I'm going to graph -3 cosine of 2x. Putting it in. Hopefully I get the same graph back. And before I do that, I'm going to go to x minimum and go to 0. And x max, I'm going to say pi, because that's where I want to see it stop. And my x scale, I'll just leave that the same and change my y min, y max to 4. Okay, so you can see it does start at -3. It's here at 0. At pi over 2 it goes up and then it goes down again. So I know that my function is correct. Okay, let's take a look at 16. We're going to, again, same thing, find an equation for the given graph in the form either y equals a sine of bx or y equals a cosine of bx. So first thing first, we have to determine whether this is a sine function or cosine function. You see it does start at 0, 0. So I know it's a sine function. So we're going to say, okay, it's not cosine because it doesn't start at like the top or the bottom. And now to determine A, I'm going to look to see how high it goes up. It goes up to 4. And because it goes up, I know that A is equal to 4. To get B, we have to get the full period. A full period of the sine function is it starts at 0, goes down, and then it goes back up again. So here's the same. The full period is pi. So if we start with the equation, I'll just write here, period is equal to 2 pi over B. And we know our period is pi. Set that equal to 2 pi over B. Solve for B by multiplying B both sides. B pi is equal to 2 pi. Divide both sides by pi. Yeah, we get the same thing. We get B equals 2. So knowing A equals 4 and B equals 2, I can go back and say y is equal to 4 cosine of 2x. And let's compare and graph. So here y equals 4. Oops, I said sine. Almost made a mistake there. So this should be sine. So y equals 4 sine of 2x. If we hit graph, okay, you can see that it does have the same shape. It goes from 0, 0, goes up to 4, down to 0, -4, back up. Okay, let's take a look at the next one, 17. It says the number of hours of daylight on a given day in city A is given by the following function, where X is the number of days after January 1st. Y equals sine of 2 pi 365 parentheses X minus 80, big parentheses plus 12. Here the function is y equals 2 sine 2 pi 365 x minus 80 plus 12. I just added the 2 in there because that was a mistake that I left down. What's the amplitude? The amplitude in this case would be 2. That's A. The period is 2 pi over B. In this case, B is 2 pi over 365. Remember, the number in front of X is your B. So we have 2 pi over 365. So multiplying, or that means times the reciprocal of 365 over 2 pi. 2 pi's would be canceled out. So your period is 365. So this cycle repeats every year to 365 days. How many hours of daylight on the longest day? Well, if you think about the midline being at 12 and the amplitude is 2, it pushes the 12 up higher 2 units. So that would be 12 plus 2, which gives you 14 hours. And then the same thing, how many hours of daylight on the shortest day? You take 12 and then you subtract the amplitude, which would give you 10 hours. So it fluctuates between 10 and 14 hours. To graph this, what we can do, so I'm going to hop on over how to do this on the homework to show you how to do it. Is we would click on the graph. And because it's a sine function, we're going to pick the sine tool. Just place it there. Put the amplitude in. 2 period. We said it was 365. The vertical shift, remember that's the number that's being added or subtracted at the end. So that was the vertical shift 12. The horizontal shift, how we get that is whatever's in the parentheses. In this case, it's the parentheses is x minus 80. So if we do that and set x minus 80 equal to 0, add 80 to both sides, we would get x is equal to 80 as our phase shift. So you would put that in, and I think then that would give us the correct graph. Okay, so our horizontal shift is 80. There's a graph, so it fluctuates from 10 hours all the way to 14, and just goes back and forth. Okay, let's take a look at this question together while we're at it. So here, this says this figure shows the depths of the water at the end of a boat dock. The depth is 4 feet below at low tide and 8 feet at high tide. On a certain day, low tide occurs at 6 a.m. and high tide at noon. If y represents the depth of the water x hours after midnight, we're going to use a cosine function of the form y equals a cosine bx plus d to model the water depth. So what this problem wants us to do is actually come up with the equation that will give us this graph. And so to do that, we need to know what A, we need to know what B, and we also need to know B and D. Okay, so A is the easiest to do. We want to see like how high does it go up and how low does it go down. So it goes up 2, it goes down 2. So that's our A. So A is going to be 2. To get B, we need to know our period. So it says, it looks like our period starts at 0 hours, goes down, and it goes back up. So it's our period, it repeats every 12 hours. So our period is 12 hours. And so the equation, we know it's the period is equal to 2 pi over b. Substitute 12 in for period. So 12 equals 2 pi over b, multiplied by b on both sides. We're trying to solve for b. And then 12b is equal to 2 pi divided by 12. B is equal to pi over 6. So we have A, we have B. Now the last thing is D. D is your midline. It's like how, remember the basic function starts at 0. Now the midline's at 6. So there's your D, that's your 6. So if we put it all together, it would be y equals 2 cosine of pi over 6x plus 6. So let's type it in and see. We get 2 more tries, right? So y equals 2, y equals is already there. 2 cosine pi over, 2 cosine, let me just do a pi over 6 x plus 6. Okay, so there we go. So that's number 24. Let me just do the last one with you as well. 25 models the average monthly temperature in degrees Fahrenheit for a city that can be modeled by y equals 17 sine of pi over 6x minus 2 pi over 3 plus 33, where your x is in the months of the year. We want to graph the function for from 1 to 12, and what is the highest average monthly temperature, and which month does this occur? So for this, we can work this out and say, what is the phase shift and the amplitude, and where should it start at? It starts at 33. So for this, I'm going to use my graphing calculator and graph it, and to compare like which of the two would be or which of these 4 would be the actual graph. So let's head on over and graph this. Okay, so here's my graphing calculator. Let's put this graph in. So we have y equals 17 sine, or sine, and then put parentheses, start over, 17 sine of pi over 6. We have x minus 2 pi over 3. And close your parentheses and then add 33. Before you hit graph, we got to adjust the windows, and I'm going to adjust it the way that it's adjusted here. So my window is going to go from the x min, looks like it starts at 1. X max, ends at 12, and it looks like it's going up by 1. So I'll say x scales 1. Y minimum, the lowest y value I see on the graph is 10. The highest y max value I see is 60. Okay, so then I'm going to put 1060. I'm just going to say y scales 10. I'll have it go up by 10s. Okay, so make sure you change your window accordingly. Hit graph. Looks like it goes from down, and then it has a peak and it goes down. The only graph that looks like that is D. So we can check our answer. And then it says like, what's the highest monthly temperature? Well, according to this, it looks like If we go up, we have 1. Looks like it's going from 2, 4, 6. And it looks like it's closer to the highest peak is right there. And we can also see the highest peak by going to my table. So if we look at that table here, going from 1, and it looks like the highest value, we keep going, looks like it's the highest value is 50 degrees. So I'm using my table here, and the highest value for me looks like 50 degrees there. It says good work. And when does that happen? Well, it happens in July, or the 7th month. So I'm going to say 7. Well, that's equal to July. So I'm going to check answer, hit OK. So there it is. All right, so I hope that was helpful. We did a lot of homework problems together. It was this video was packed because we were doing the cosine function, sine function. Please let me know if you have questions while doing the homework. You know how to reach me. And I hope this recording was helpful.